Hi guys, welcome to Tech Geek. So again, I'm back with today's LeetCode problem. That's minimum moves e- to equal array elements. That means you have to make the array elements equal, and how many moves you have to do minimum that you have to tell. So that's a LeetCode medium question. You can see LeetCode medium 462. Before beginning with this, I'd like you to please I like to request you, so sorry. Yeah, please like, share, and subscribe to my channel. In case of any queries, do let me know in the comment box. I'll be happy to help you out in every particular process. And not just this, if there are interview process, questions, or any particular approach you get stuck to, please do that. And before showing the solution too, I'd like to request you all. I actually explain the approach and the solution is only for those if you get stuck. So don't blindly go towards the solution. You should stop the video, try it on your own, and if in case your test case or anything fails, in that case you should go after the solution. So if you even if you are a beginner, please give it a shot. You should not do just copying of the code or something like that, because that won't help you out in any particular way. So that's what I wanted to say. Now let's see how and what the question says for. Okay, so the question says we have been given an array that's nums of size n. Return the minimum number of moves that are required to make all array elements equal. That means how many number of moves should we do to make the array elements equal. Now in one move, either you can do plus one, increment the element, or decrement the element, okay, by one. So either we can make an element with plus one or minus one, depending on the condition. Now test cases are designed so that we fill 32-bit integer. Okay, they have been given one example. Okay, so example here is 1 2 3. So let's consider each and every case. Okay, and let's begin here. We have been given 1 2 and 3. Okay, this is sorted, but not in every case you get sorted. The very first thing, let's consider we want to make 1 as the equal element. It's just a hit and try, so don't think. So what we need to do, we need to subtract it 2 times, like this minus 1, and this would be subtracted twice, minus 1 and minus 1. That is 2 moves of this and 1 moves of this. So in total we require 3 moves if we want to make all 3 as 1 1 1. Okay, the next condition would be to make all as 2. To make all as 2, what we need to do, we need to put 2 1 here and minus 1 here. So obviously 1 plus 1, this will be 2. This is already 2, so no moves required. And again this is 2. So here the output is 2. Again let's check for 3. We'll check all 3 conditions here, though that is not what we have to do in this question, but just for explanation I'm doing. If you want to do 3, again this would be same. Add 1 here, that's 1 move, add 1 and again 1. So in total here also we need 3 moves. So overall, looking to this, which is the smallest number of moves that are required, this is 2. So this is what our actual solution should be. Now this was a hit and try. Let's say you have a n number of elements, then how can you do that? You cannot check on your own like plus 1 minus 1. No, every time you cannot. So what you are going to do in this case? Okay, let's look at the second example first. 1 10 2 and 9. As I said, it won't be sorted every time, so you get that 2 1 10. So sorry for my writing. Okay, 1 10 2 9. Now still therefore, if you try to do, it will take much more time as compared to 1 2 3. But still again trying, checking for 1, checking for 10, checking for 2, checking for 9. That's not what we need to do in our problem solving. We need to get a proper approach, right? So what we have to do is first sort the elements. Okay, 1 2 9 and 10. Okay, now you know one thing, we need to get an element that should be chosen, that is an appropriate thing which will give us minimum numbers. That is the element which is quite closest to each element, right? That is what we need to get. So I guess for getting a closest element, we must be aware of the word median. If you guys know the statistics, median, that's a middle element. Obviously, in so many elements, the middle one would be the one that is approximate or easy to reach. So what we'll do, we'll find the median. How many elements are there? 4. So let's say this array was A, so length by 2. Okay. What is length by 2? That is the way we find the median. I hope that is what you guys are aware of. So the median here would be A of 2. Okay. A of 2. So 0, 1, 2. So this is the element. That's 9. So that means the element that is to be made, like all other elements, should be made equal to this element. Okay. Now how we'll do? We'll run a loop from I equals to 0 to n minus 1. And we'll take one minimum moves, let's say m for now. This is 0. We'll find the absolute difference between this middle element and all other elements, and we'll sum them up. That is, these are the minimum moves. So minimum moves plus equals to would be absolute difference. Why absolute difference? Because we don't want to subtract. Even if we are subtracting, then also we are adding it as a move. That is A of mid. Here it is 9. I am writing A of, it should be A of mid actually, and A of I. Okay. This should be what we need to do. Now let's check. Okay. For this question, let's check it out. Okay. First is 1 minus 9. Absolute difference 8. 2 minus 9, again 7. 9 minus 9 is 0. 9 minus 1 is 10. 8 plus 8, 60. So that is the minimum number of moves that are required. You can see even the solution says they are 16 moves. Right? Now coming to a question, why didn't we take 2? Okay, so let's check for 2 also. We'll get to know. If you take 2 as the median, okay, then the difference is 1, 0, 7, 8. So you can see the result is again the same. If you remember, in median there was a condition. If there are even elements, we take this plus this as an average. But in this case, we are not going for average. So when there are even number of elements, you can take either this one or n minus 1. That's mid minus 1. Both will give you the accurate result. Okay. But if talking about odd number of elements, then this is the only one. That is to generalize the question, not to check it should like n is even or odd. This is the particular thing that we should go up. So I guess this is clear with you all. What you have to do: sort the array very first. Second, find the median, middle element. Then find the absolute difference between all the elements and the middle elements. Sum them up. Once you sum them up, you know what are the minimum number of moves required. So this is basically an easy question if you know the concept. Now let's look at the code. Again, a request to each one of you. Don't blindly follow the code. Go up with your own solution. Again, sorting the array, finding the median, making minimum moves as 0, traversing the array, adding the absolute difference and returning the minimum moves. So this was just an easy thing that you need to do. And for this, you know that it would be O of n log n. Why O of n log n? Because you're sorting the array. So sorting is O of n log n. So that is the time complexity, and talking about the space complexity, that's order of 1. So this is what the question says. In case there are any queries regarding the question, complexities, approach, any other approach that's beneficial, do let me know in the comment box. Thank you and keep following Tech.